Okay, so in this video, I am going to show you an example of how to identify any outliers in a set of data. So the set of data that I'm going to create is actually a stem and leaf plot. So some of you might have seen, oops, sorry about that. Some of you might have seen some of these stem and leaf plots and weren't really sure how to figure out what the data is from them, but they're not really that hard. I'll just kind of go through and give you a quick example. All right, so on the left side of my stem and leaf plot, I've got 0 through 7. On the right side, I've got a 5, and then a 7, 9, 2, 5, 6, 3, a 6, and then there's nothing in the 5 and 6, and then a 5. So it could look like a table or not, but basically if I were to list the data set that comes from the stem and leaf plot, 0, 5 is just the number 5. 1, 7 is the number 17. 1, 9 is the number 19. 2, 3 is the number 23, and then there's a 2 with a 5, so that's 25. 2 with the 6, so that's 26. Then go down to the 3. The 3, 3 is a 33. 4, 6 is just 46. There isn't anything after the 5 or the 6. That means that there aren't any data points in the 50s or the 60s, but then we have a 7 and then a 5. So that's the number 75. So this is all the data listed out from this stem and leaf plot. So this is that. All right, so when it comes to identifying outliers, we need to, first of all, well, there's this formula that says the outlier, there's a couple of them. So outliers are numbers that are less than Q1 minus 1.5 times the inner quartile range. Or if you have outliers on the upper side, so this is the lower end. So if you have numbers on the lower end, like maybe this 5 is an outlier, but we're going to see if it fits to this criteria. If you have outliers on the upper end, the outliers have to be numbers that are greater than Q3 plus 1.5 times the inner quartile range. So looking at these couple of formulas, it tells me I need to figure out what Q1 and Q3 are, and I also need to figure out what my inner quartile range is. So these are basically your formulas for your outliers. So now looking at the data, if I count the number of pieces of data I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a nice odd set of data. So my middle number is going to be the 5th number. So this is 25. So this is my median. So then to the left of my median, I have 4 numbers. So the Q1 is going to be the median of these 4 numbers. So it's going to be the average of between 17 and 19. So the average between 17 and 19, or Q1, is going to equal 18, because that is, if I added 17 and 19 together and divided by 2, I'd get 18. Also, 18 is the middle number between 17 and 19. For my Q3, though, I'm going to take these numbers, and if I subtract, or if I add, 33 plus 46 divided by 2, that will give me my Q3. So 33 plus 46 is going to be 79. Divide that by 2, I get 39.5. So my Q3 is 39.5. So now that I know my Q1 and my Q3, I can find my inner quartile range, or IQR, because you just find that by subtracting Q3 minus Q1. So my inner quartile range is going to be 39.5 minus 18. which then is equal to 21.5. So that is my inner quartile range. All right, so now that we have all the numbers we need for our formula here, any outliers on the lower end are going to be less than Q1, which is 18, minus the product of 1.5 times my inner quartile range, which is 21.5. So if I take 1.5 times 21.5, I'm going to get 32.25. So my outliers on the smaller side, on the left end of the set of data, if I were to subtract any outliers that I had, would be less than 18 minus 32.25, a negative 14.25. So if I look at my original set of data, I don't have any values that are even negative. So there are no outliers on the left side of the data. But now we're going to check the right side, because it says or an outlier or outliers are anything that's greater than Q3, and Q3 is 39.5 plus the 1.5 times the inner quartile range and 1.5 times, don't want it to look like an X, so times 21.5, like we said earlier. If I multiply that out, I get 32.25. So outliers on the upper end of the data, if I add 39.5 and 32.25, I get 71.75. So an outlier would be anything that's greater than 71.75. Well, if we look at our data, we do have a number that is above 71.75, which means that 75 is an outlier. Hopefully that helps you find out or identify your outliers. If you need more help, let me know.